Hello students, today we are going to start question number 3rd of exercise 12.2. In 12.2, two questions are remaining, question number 3rd and I think question number 5. So these two questions we have to finish. Let us see first question number 3rd. We are doing the topic of distance formula in chapter number 12, Introduction to Three-Dimensional Geometry. So see the first part, we have to prove that the given vertices are the vertices of an isosceles triangle. See, isosceles triangle is that kind of triangle which have two sides equal. So here, if we are able to prove the two sides are equal, then we can say that the triangle is an isosceles triangle. So let us see the part number 1. In the first part, what they are saying to us, we will suppose the three vertices as A, first vertex I am supposing A, 0, 7 and minus 10. Second vertex I will suppose by B, that is 1, 6 and minus of 6. And the third vertex I will suppose as C, that is given here as 4, 9 and minus 6. Okay, now first of all we shall find out the three values. First I am finding the value of AB, means I am applying the distance formula and getting the value of AB. The method will be same. We shall subtract the x coordinate, y coordinate y coordinate and the z coordinate. So first x coordinate, it is 0 minus 1 whole power 2 plus 7 minus 6 whole power 2 and plus minus of 10, and when we shall subtract minus of 6, so this minus sign and the minus sign comes between them will multiply, become plus, so whole power 2 again. Now we shall simplify further, so it can be written as under root of 0 minus 1, that is minus 1, so this will come 1, 7 minus 6 again 1, this is also 1, and here it will remain 4, so square of 4 will be equal to 16. So this will become as under root of 18. Under root of 18 I can write down here as 2 into 3 into 3. Okay, so pair of 3 is complete here and 3 we can take outside. So finally the value of AB will come here as 3 under root of, this is the first value. Okay, now similarly we shall find out the second value. Now second value is BC. If the value of BC also come 3 under root of 2, then we can say that triangle is equilateral and we need not to find out the third value in that case. Okay, suppose if the second value means BC doesn't come equal to AB, then we shall go to the third value. So here let us find out the second value BC is equal to under root. In the same manner we shall apply the distance formula, 1 minus 4 whole power 2 plus 6 minus 9 whole power 2 and plus minus of 6, and again sorry, in the same manner that second minus of 6 will become plus because minus minus will multiply, and this will be whole power 2. Okay, now further we can say 1 minus 4 will be equal to minus of 3 and square of minus of 3 will be equal to 9. So this will be 9 plus 6 minus 9 again minus of 3, that is also 9, and plus this will be 0. So this is also coming here under root of 18, and you can see under root of 18, if I find out the factor, so 3 pair of 3 will be completed and the value of BC will also I will get as 3 under root of 2 units. So now you can see our AB and BC are same. So we can say that since the length of the side AB is equal to BC and we got in the triangle two sides equal, so we can say that sorry, so we can say that therefore triangle ABC. Triangle ABC is an equilateral triangle. Okay, this is the first part. Now similarly, let us see the second part. In the second part, we need to prove the triangle is a right angled triangle. So for this, first of all, we need to apply a Pythagoras theorem, and then accordingly we need to find out the answer. Means Pythagoras theorem says the square of hypotenuse is equal to the sum of the square of other two sides. So in short, here we can say that the square of one side should be equal to the sum of the square of other two sides. So we can say that by Pythagoras theorem, the triangle will be a right angled triangle. So let us write down the vertices once again. We have given that vertices here, that we'll copy from here. First of all, we shall mark second part here, and what are the given vertices that we can see. These are the given vertices to us. So we shall mark these three vertices as P. First one is P, 0, 7 and 10, comma, Q, -1, 6 and 6 again, and third one is R, -4, comma, 9, comma, 6. Let us find out the three values. Now since here we required the square of the sides, so what we will do it, we shall directly find out the square without applying the square root. For example, suppose if you see here, I have found the value of AB or the BC, that is coming in the square root. But if I put up the square on BC, then on the either side of the equation, square root will not come. So directly we shall find out that value here. So here first I am finding it, square of PQ. So PQ square is equal to, now root symbol will not come, 0 plus 1 whole power 2 plus 7 minus 6 whole power 2 plus 10 minus 6 whole power 2. Okay, or else if we solve further, so 0 plus 1, that is 1, 7 minus 6 again 1, and 10 minus 6, that is 4, square of 4, sorry, so that will be 16. And then we can say that therefore the value of square of PQ will be equal to here 18 units. Now similarly we can find out the value of QR and the value of PR. So now I am finding the QR square. So QR square is equal to -1 plus 4 whole power 2 plus 6 minus 9 whole power 2 and plus 6 minus 6 whole power. Now if we solve it further, -1 plus 4, that is 3, and square of 3 is 9. 6 minus 9 is also minus of 3, and square will become 9, and plus 0. So we can say that QR square will be equal to 18. Both are coming same only. Part number 1 and 2 vertices are same. 0, 7, 10, -1. Okay, only signs are different little bit. The vertices are same only. Okay, so let us see, the QR square is coming here 18 units, right? Now we shall find out the value of PR square. Okay, so let us see the third and the last value. PR square is equal to 0 plus 4 whole power 2, 7 minus 9 whole power 2 and plus 10 minus 6 whole power 2. Right? Now if we solve it further, so this can be, first one can be 16, second one can be 4, and third one can be again 16. So here 16 plus 4 20 and 20 plus 16, this will become 36. So square of PR will be equal to 36. Now see, if I add PQ square plus QR, so that will be equal to 18 plus 18, and sorry, 18 plus 18 will become here 36, and 36 is the value of PR square. So we can say that therefore PQ square plus QR square, therefore we can say PQ square plus QR square will be equal to PR square. So now see, here PR will become the hypotenuse and PQ and QR will be the other two sides of triangle which have Q point common. Means Q will be the point of perpendicular here. So we can say that therefore triangle PQR is a right triangle at Q. Okay, that we can see. Let us see the part number third now. In the third part, see what they are sorry, what they are saying to us. They are giving to us in the third part to prove that the given vertices are the vertices of right angle triangle. Okay, so see, there are four vertices are given and we have to prove that they are vertices of, sorry, I said right angle triangle, vertices of parallelogram. Okay, so if we want to prove that these are the vertices of parallelogram, so we shall apply the properties of parallelogram over here. The basic and the very simple property is the opposite side of both the quadrilateral, sorry, both the opposite sides of quadrilateral, if they are equal, then we can say it is a parallelogram. Means for example, suppose if I have parallelogram ABCD, then AB and CD should be equal, as well as AD and BC should be also equal. So both pair of opposite sides, if it is equal in a quadrilateral, we can say that it is a parallelogram. But remember, if you wish to prove rhombus or a square or a rectangle, then some more properties we need to insert over there. Okay, for example, in the case of rhombus, if you are going to prove all sides are equal, then we can say it is a rhombus. But in the case of square, you need to prove their diagonals are also equal. Means you need to prove all sides are equal as well as the diagonals are also equal. Same way in the case of rectangle, you need to prove both pair of opposite sides are equal as well as the diagonals are also equal. Because both the pair of opposite side, if it is equal, it could be a parallelogram or it could be a rectangle. So for rectangle, additionally you need to prove diagonals are also equal. Similarly, in the case of square and rhombus, if you are proving all sides are equal, basically it will be a rhombus. But if you want to prove square, then you have to prove additionally diagonals are also equal. Okay, so let us see this question, part number third. In this, we shall take first of all these four vertices. These four vertices we shall suppose as ABCD. I will copy here this one. It will be visible to us. Okay, first I am supposing the four vertices over here as A, B, C and D. So first A will be -1, 2, 1. Then B, I am supposing here 1, -2 and 5. C, I am supposing here 4, -7 and then 8. And last one D, I am supposing here 2, -3 and then 4. Okay, so let us start. Last one is 4 -7 8 and 2 -3 4. First of all, I will find out the value of AB. Okay, you can find out the square of AB also, because ultimately if AB is equal, then square of AB and CD will be also equal. So here we shall find out first the value of AB is equal to, in the under root, yes, first AB minus 1 whole power 2 plus 2 plus 2 whole power 2 and plus 1 minus 5 whole power 2, right? So is equal to 1 minus 1 and minus 1, that will become minus of 2, and square of minus of 2, that will be 4. 2 plus 2, that is 4, so this will be 16, and last one is also 16. 16 plus 16, 32 plus 4, 36. So if we find out the square root, it will come 6 units. Similarly, we can find out the second value here, BC. Okay, I am finding in sequence. Later on, we shall compare. Okay, first BC 1 minus 4 whole power 2. Second one is here minus of 2 plus 7. And third one is here 5 minus 8 whole power 2. Okay, so we can find out now its value here. So it can be equal to under root of 1 minus 4, 3. The square of 3 is 9. 7 minus 2, 5. The square is 25. And again it will be 9. So 25 plus 18. Looking little odd over here because first value is coming very proper. We shall rectify if any mistake we have done, if it is not coming equal to the other sides. Okay. Similarly, now I will find out third value, CD. Now CD should also come here 6. Okay. So CD 4 minus 2 whole power 2. Second one minus 7 plus 3 whole power 2 and plus 8 minus 4 whole power 2. Now let us simplify. Okay, 4 minus 2, that will become here 2 and square of 2 is 4. Similarly, 3 minus 7 is 4, square of 4 is 16, and 8 minus 4 is 4, square of 4 is again 16. This will be, you observe, 16 plus 16 and plus 4. Already we have written as 6 units. So now this can be written as 6 units over here. Okay, so third value we got over here. Now let us find out the fourth and last value. That will be dA. So dA is, okay. First, now see here what is D and A is given to us. From D, I am subtracting the coordinate of A. So 2 minus minus 1. This will be 2 plus 1 whole power 2. Then minus of 3, minus of 2. So plus minus of 3 minus of 2 whole power 2 and plus 4 minus 1. Now let us simplify. So is equal to, this one is 2 plus 1 3, square of 3 is 9, minus 3 minus 2 minus of 5, and square will be 25, and 4 minus 1 3, square of 3 is 9. So this is also coming here under root of 43 units. So we can say that since AB is equal to CD, and one more thing, AD is equal to BC. So we can say here, therefore ABCD is a parallelogram. Okay. Let us see the last question of the exercise. Now I am taking question number 5. Question number 5 is actually the question of locus. Locus, I tell you, it is nothing, it is given one condition, and with the help of that condition we need to frame the equation. And after framing the equation, we have to simplify the equation and bring the equation into its standard form, means in the form of the variable. Now depend upon the equation variable, you have considered one variable, two variable or three variables. Okay, so here just with the help of given condition we will frame one equation, and that equation will try to simplify to get the in the simplest form. Okay, so here that is called as the locus. So here you see what is the question given to us. Find the equation of the set of the points P, the sum of whose distances from A and B is equal to 10. Means if I take the distance from P to A as well as if I take the distance from P to B, okay, means value of PA and value of PB. If I add both of them, that will be equal to 10. That is given in the question. So let us see how we can solve this question over here. First of all, we shall find out the value of PA. So we shall suppose here, let the coordinate of P will be XYZ, because P will be also lie in three-dimensional plane. So let P point, let coordinate of point P, coordinate of point P is X, Y, Z. Okay. Now let us find out first the value of P. So PA is equal to under root of. See, now PA I am finding it. So from XYZ I will subtract the coordinate of A. So that will be X minus 4 whole power 2 plus Y minus 0 whole power 2 and plus Z minus 0 whole power 2. This will be the value of PA, right? Similarly, let us find out the value of PB. So value of PB will be equal to under root of, okay, here also it will be X plus 4 because the X coordinate of B point is given minus, that will become plus Y minus 0 whole power 2 and plus Z minus 0 whole power. So we have kept ready the value of PA and PB. Now we shall talk about the given condition. See, the length of PA and the length of PB. If I add, so addition of both of them is equal to 10. That is given in the question, or that is our condition as I have told you earlier. So according to the condition or according to the question, we have given that PA plus PB is equal to 10. This is our given condition, and this condition we have to put the values whichever we knows, and we have to simplify this equation. We have to simplify this equation into the simplest form. Okay, so let us put up the value of PA and PB. So value of PA is in the under root X minus 4 whole power 2 plus this will be Y square now, and this will be Z square plus similarly under root of in the PB X plus 4 whole power 2 plus Y square plus Z square is equal to 10. Now, see, this equation you can't simplify in this manner until and unless you manipulate the given equation. Now, for manipulation, what we shall do, these two square root until and unless they remain together, we cannot simplify them. So, we need to break. So, once square root, I will send onto that side. Okay. So, here we can write down, which implies that under root of x minus 4 whole power 2 plus y square plus z square, okay, is equal to this one I am sending on to that side. So 10 minus under root of x plus 4 plus y square plus z square. Now what shall we do it? Since this square root has become alone, so now we can square it, the whole equation. We will write down squaring, sorry, 1 second, we'll write down squaring on both sides. Squaring on both sides. So if we are doing this squaring, so see on the LHS that will become free from the root, means it will become x minus 4 whole power 2 plus y square plus z square. Okay, but when we do the squaring on the right side, in the case of right hand side, it will become a formula of a minus b the whole square. So we shall apply the formula of a minus b the whole square. So this will be, first one square is 100, second term square, here also root will be cancelled, so x plus 4 whole power 2 plus y square plus z square. But the third term will come minus of 2 into a into b. So 2 into a will be here 10 and b will be again coming in the root only. Okay, so this we shall write down in root. So our equation will not be at this stage completely. So x plus 4 the whole square plus y square plus z square. One thing we can do it here, y square and z square, that we can cancel. Okay, now we shall open x minus 4 the whole square and x plus 4 the whole square. So x minus 4 the whole square I am going to open. That will be x square plus 16 minus 8x is equal to 100 plus x plus 4 the whole square. So x square plus 16 plus 8x, okay, minus 20, and then under root of this term will be as it is, x plus 4 whole power 2 plus y square plus z square. Now again you see, again two terms are going to cancel. One is x square and second one is 16. These two terms we can cancel. Okay, now see this 8x we can send on to that side. 8x also, 100 also. Why we are sending it, that I will tell you. Minus of 8x, if I am keeping as it is, 8x is also coming here, that is minus of 8x, and then minus of 100 is equal to remain here minus of 20. Now see, if I am not sending these terms onto that side, then I need to remove the root from this particular term. So again I need to square it. Again if I will square, it will become in the form of a minus b the whole square. For example, only 8x I am sending onto that side and 120 if I am keeping onto this side. So in that case, again it will become a formula of a minus b the whole square and the pattern will continue till infinite. So again we need to keep this particular term which is in the square root need to be alone, as we have kept this term alone. So if after squaring it, that term's root completely eliminated. The same way it will be done here also. So we can write down this one as x plus 4 whole power 2 plus y square plus z square. Now minus sign we will take common from the LHS as well as the RHS, and this will become 16x plus 100 is equal to, we can do one thing, we can take some more terms common. Okay, fine, we can take in the next step minus of 20 and then under root of x plus 4 whole power 2 plus y square plus z square. Okay, now minus sign and minus sign we can cancel it. Now see, if we take some more terms common, for example if I take 4 common, okay, suppose if I take 4 common, remaining is here 4x plus 25 is equal to 20 under root of x plus 4 whole power 2 plus y square and plus z square. Now see, from 4 we can cancel 25 times. Now we shall perform the squaring on both the sides. So we shall write down further again squaring on both sides. Okay, so 4x plus 25. If I will square, after opening it, it will be in the form of a plus b the whole square. So first one is 16x square. Second one is square of 25, that is 625 plus 2ab. 2 into 4x into 25 is equal to, now here square of 5 is 25, in bracket this will be x plus 4 whole power 2 and plus y square plus z square. Right, now see, the square root has been completely removed. Now little bit simplify over there. So 16x square will be as it is, 625 will be also as it is. Okay, this 2ab we shall simplify. So 25 into 400, 100 into 2, that is 200. So 200x is equal to 25 into the bracket x square plus 16 plus 8x plus y square plus z square. Okay, now 25 I am going to multiply inside. So it can be the LHS I am copying as it is here, 625 and then plus 200x is equal to 25 x square. 16 into 25, I think it can be written as 400 plus 400 plus 25 into 8, that is 200x, and 25 y square plus 25 z square. 200x and 200x will be cancelled. These two terms 16x square and 625 we can send onto that side. So it can be written as, or 400 we can bring on this side and 16x square I can send onto that side. So 25 minus 16, that will be 9x square plus 25y square plus 25 z square is equal to 625 minus 400 will be equal to 225. Or you can write down this equation as 9x square plus 25 y square plus 25 z square minus 220 is equal to 0. This is your answer. This is simplest form of the equation, which is given in the form of condition as PA plus PB is equal to 10. Next time we will start from the exercise 12.3. Okay, thank you.